All right. Hey, everyone. Welcome back for another deep dive. This one's been requested a bunch, so I know there are some big brains out there ready for this. Today, we're talking about Aryabhata.
Oh, yeah.
And just to give you a little context, if you haven't heard of them, Aryabhata was this brilliant Indian mathematician and astronomer, and he lived way back, like way, way back in the 5th century
Yeah.
during the Gupta period, so we're talking ancient India.
Right.
And he's credited with making some really groundbreaking discoveries in both astronomy and math. Discoveries that honestly still kind of blow my mind. We use them every day.
Absolutely.
So for this deep dive, we're going to be looking at some excerpts from a document called India Notes EQ4.pdf.
Okay.
It lays out some of Aryabhata's most significant contributions, and we're going to try to unpack them together, really get to the heart of what made him such a revolutionary thinker and what his legacy means for us today. I'm excited to get into this. This is going to be a fun one.
Yeah, me too.
Okay, so to kick things off, can you maybe give us a little bit of background on the Gupta period? I mean, I know it's considered a golden age in Indian history.
Absolutely. Yeah. So the Gupta period, spanned roughly from the 4th to the 6th century CE. And it was, as you said, a golden age. And that term gets thrown around a lot. But when it comes to the Guptas, it really, truly is an apt description.
Oh, yeah.
There was this incredible flourishing of intellectual and cultural achievements across a wide range of fields. We're talking, as you mentioned, significant advancements in mathematics and astronomy,
Right.
but also in art, in literature, in philosophy, in medicine, you name it.
Oh.
They also made great strides in trade and commerce. It really was this period of remarkable prosperity and innovation.
So Aryabhata wasn't just some lone genius popping up out of nowhere.
Yeah.
He was part of this whole, vibrant intellectual scene.
Exactly, exactly. He was both a product of his time, benefiting from that rich intellectual environment, but he was also very much a shaper of his time. His discoveries pushed the boundaries of knowledge in really profound ways.
All right, so speaking of those discoveries, let's jump right in.
Mhm.
He's most famous for his work in astronomy, right? So what were some of the things that he figured out about the universe that were so, groundbreaking at the time?
Yeah, I mean, where do we even begin? He had a lot of revolutionary ideas. One of the most significant was his proposal of the heliocentric model of the solar system,
Okay.
which, as you know, states that the Earth revolves around the sun.
Right, right. And that seems so basic to us now, but back then that was a pretty radical idea, right?
Oh, absolutely. It was a complete departure from the prevailing view at the time, which was the geocentric model.
And that said that the Earth was the center of the universe.
Exactly, yeah. They thought everything revolved around us. The sun, the moon, the stars, all of it. So Aryabhata's idea that the Earth was actually orbiting the sun, I mean, that was a major paradigm shift.
Yeah, like shattering everything people thought they knew about the universe. I mean, to even conceive of that idea back then is pretty wild.
Totally. And to then go and provide evidence to support it. I mean, just think about the limited tools and technology they had at their disposal. It's just remarkable.
So how did he prove it? What did he use to make these calculations?
Well, it wasn't so much that he had these sophisticated instruments. A lot of it was based on careful observation.
Okay.
Meticulous tracking the movements of the celestial bodies and then applying really advanced mathematical reasoning to make sense of it all.
So he was watching the skies, like really watching them and crunching numbers.
Yeah, exactly. He had to really challenge the assumptions of his time and think outside the box to come to these conclusions.
That's really cool. So that was the heliocentric model, right? Earth goes around the sun. But I think he also figured out something about the Earth's rotation, right? Like how it spins on its axis.
Yes, exactly. He also deduced that the Earth rotates on its axis, which we now know is what causes day and night.
Right.
And again, this was a pretty revolutionary concept at the time.
So, okay, he's revolutionizing our understanding of the Earth and its place in the solar system. But what about the other celestial bodies, like the moon and the planets? What did Aryabhata discover about them?
Well, one of his key insights was that the moon and planets don't actually emit their own light.
What?
Yeah, he figured out that they shine because they're reflecting sunlight. And this discovery was really crucial for understanding things like lunar phases.
Okay, so that's why we see a full moon, a new moon, all the phases in between.
Yeah.
It's the way the sunlight hits the moon as it orbits the Earth, right?
Exactly. We're only ever seeing half of the moon illuminated, but the portion of that illuminated half that we can see from Earth changes as the moon moves through its orbit.
Right. Right, that makes sense.
Okay.
What about eclipses? I remember reading that he had some insights into those as well.
Oh, absolutely. He was able to explain how eclipses occur based on the alignment of the sun, the earth, and the moon.
Okay, so walk me through it. How does that work?
Well, so a solar eclipse happens when the moon passes directly between the sun and the earth,
Right.
blocking the sun's light and casting a shadow on parts of the earth. So for people on earth within that shadow, it looks like the sun is disappearing, either partially or completely, depending on where they are.
So it's like the moon is photobombing the sun.
Haha, that's a great way to put it.
I mean, that must have been pretty freaky for people back then. Like the world is ending.
Yeah, I can only imagine. And then there are lunar eclipses.
Right, which is the opposite.
Exactly. In a lunar eclipse, the Earth is the one that's positioned between the sun and the moon.
Okay.
So the Earth's shadow falls on the moon, making it appear dim or even reddish.
So cool. I mean, it's incredible that he was able to figure all of this out just by observing and calculating.
Right. It speaks volumes about his powers of observation and deduction.
Okay, so we talked about Aryabhata, the astronomer, right? The guy who revolutionized our understanding of the cosmos. But he was also a brilliant mathematician. So what about his contributions to math? What were some of his key discoveries there?
Oh, there are so many. But one that really stands out is his work on the base 10 number system.
And that's what we use today, right?
Yes, the very same. It's the foundation of modern mathematics, and Aryabhata played a pivotal role in its development. And key to that was his concept of zero.
Wait, zero. Zero wasn't a thing before Aryabhata.
Not in the way that we understand it today, no. Think about Roman numerals, for example.
I, 3, 3.
Right, exactly. There's no symbol for zero there.
Oh, wow, that's true.
So to represent larger numbers, you had to keep inventing new symbols. It made calculations very cumbersome. But Aryabhata, he introduced zero as both a placeholder and a number in its own right.
Okay.
And that was revolutionary. It simplified calculations immensely, made everything so much more efficient, and it paved the way for all sorts of mathematical advancements.
My mind is kind of blown. I never thought about how radical the concept of zero was. It just seems so basic to us now.
Right. It's so fundamental that we take it for granted. But it was a massive breakthrough, and we owe a lot of our mathematical progress to Aryabhata's insight.
Amazing. And I know that he also did some groundbreaking work with, is it pi? The mathematical
Oh,
concept?
yes, absolutely. Pi. He made a really significant discovery about pi, recognizing that it's an irrational number.
Okay, back up a sec. Remind me what an irrational number is. It's one of those things I learned in school and then promptly forgot.
Sure, so an irrational number is a number that can't be expressed as a simple fraction. It's a number that goes on forever after the decimal point, without repeating.
Ah, okay. And pi is like the ultimate irrational number, right? It goes on and on and on.
Exactly. And that means it's incredibly important when it comes to working with circles, because pi relates a circle's circumference to its diameter.
Okay, let's break that down a little bit. Circumference is the distance around a circle, right?
That's right. And the diameter is the distance across the circle going through the center.
Okay, I'm picturing it. So how does pi connect those two things?
Pi is the ratio of the circumference to the diameter. So if you divide the circumference of any circle by its diameter, you'll always get pi.
So the formula for circumference would be like c equals pi times d or something like that.
You got it. C equals BED. And we can also write the circumference in terms of the radius, which is the distance from the center of the circle to the edge.
Okay, so half the diameter.
Exactly. So the formula would be C equals 2R.
All right, and we can't forget about the area of a circle. That's the space inside the circle, right?
You're on fire today. And the area is calculated using pi and the radius squared.
Okay, hold on. Radius squared.
That just means you take the radius and multiply it by itself. So the formula is A equals R2.
Okay. So pi is kind of everywhere when you're talking about circles.
Absolutely. And Aryabhata's understanding of pi as an irrational number was a huge step forward in understanding circles and all their mysteries.
It's crazy to think that these formulas that he developed, like 1,500 years ago, we're still using them today.
I know. Whether you're an engineer designing a bridge or just trying to figure out how much pizza dough you need, pi is there working its magic thanks to Aryabhata.
It really makes you appreciate the power of these fundamental mathematical principles, how they transcend time and culture.
Definitely. It shows how interconnected knowledge is and how discoveries from centuries ago can still have a profound impact on our lives today.
And that's what I love about these deep dives.
Yeah.
We get to explore the work of these incredible minds from the past and see how it shaped the world we live in today.
It's like like connecting the dots across history.
Exactly. And on that note, I want to thank you and thank all of you for listening in today. We had a chance to dive deep into the life and work of Aryabhata, this extraordinary mathematician and astronomer from the Gupta period.
It was a great conversation.
And, as always, I'm left with more questions than answers. Like, what other mysteries of the universe did Aryabhata unlock that we haven't even touched on today? And how did